All right, now we're recording. There we go. Yeah, share screen's working well, I think. Oh, that's just a copy. Yep, it's on yours too. I'll be right back. How are you guys getting your groceries?
Costco.
Is somebody going there physically, or are you guys having it delivered?
We're not ordering them. We're going there.
We do the smart cart.
Smart cart.
Or I think that's what it's called. They pick it up.
Instacart?
Yes, sorry. Instacart, sorry. I feel like
Yeah, we're ordering all our food from there.
Yeah, Instacart. I just feel like it's a bit safer because everybody goes to the shopping centers. And then so you're more likely, a lot more likely to catch something by going to an actual place. We'll start in a minute and a half here. Right now, you're trying to graph all these situations. Did we already do the first one here? I feel like we did the number 5.
Wait, this is A, X minus P, X minus Q, right?
Yes. Did you guys do Vertex Form? Not Vertex Form, Intercept Form.
Root form, yeah.
Did you do Intercept Form last year with Mr. Knaus?
I don't remember.
I think we did.
I don't remember ever.
Oh, we did. We did.
You did? I think we did number 5. I don't know if we did number 6. Let's start with number 6. What do we do? We're going to identify P, we're going to identify Q, we're going to identify that, we're going to get the y-intercept. You get a ton of points from this way. I feel like you get the most from this form. Oh, 8:30, good morning. All right, well, we already started recording, so let's get moving. So this is the A, X minus P times X minus Q, right? X minus P, so 4 must be P, not -4. And X minus Q, since that's a plus, that would have to be a -1 to make that positive. the x coordinate of the vertex is the average of P and Q. So you come back up here and average these two numbers. 4 plus negative 1 is 3. 3 divided by 2 is 1.5. You plug that in for x here. So here we go. 1.5 minus 4 is negative 2.5. And then negative 1, positive 1.5. So this is 2.5. Interesting. I feel like you're always going to get a square here. Didn't we do that on the last problem? Because it's the average, it's exactly between these two, right? And if it's between these two,
then when you add them, you're gonna get a certain number, and when you subtract them, you're gonna get the same number, but the opposite.
then when you subtract that same distance, yeah, you're going to get the same always. What sign are you going to get though? If these are opposite signs, you're going to get negative. If these are the same sign, you should get positive. So the two, okay, but how would you determine what this number is going to be though? What's the shortcut to finding what that's going to be?
I don't get how you got 1.5.
Oh, here, it's the average of P and Q.
Oh yeah, I forgot.
Where'd you get 2.5?
By plugging that x coordinate back in.
Oh, okay.
But it seems like in the last problem you get a square. It seems like you're going to have to get a square here. But how is there a way to get that number that you're going to be squaring as a variable for all problems to make it a little tighter?
I'll work on it.
Yeah, you can look into it. Okay, so this is negative 6.25 times 2 is negative 12.5. Okay, so there's the vertex. The y-intercept. The y-intercept is when, it's A, what did we say? The y-intercept is at A, P, Q, right?
Yes, I believe.
So it's 2 times 4 times negative 1. Or all you have to do is, you're on the y-axis when x is 0, you can plug 0 in here and get it that way. Okay, all right. It would switch the signs. It would make that negative 4 and positive 1, but it wouldn't have an effect on the product. So it'd be negative 8. The y-intercept is negative 8. Okay. Now I don't know if you need me to graph. Well, it's not all the. There's one more point we want to get, so I might as well graph it. I think you guys can see. Okay. Let's see. 4, negative 1. The vertex is over there. It opens up. Oh, I need a lot down here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sorry. It's going to be way down there. Okay. So here we got y-intercept is at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we have P is at 4. Remember, what are P and Q? They're roots. P and Q are X-intercept points. They're the root. They're where they're located along the x-axis. So at 4 and negative 1. That's what P and Q are. Okay? The vertex is at 1.5, negative 12.5. There. Okay? Axis of symmetry goes through the x-coordinate of the vertex. You guys are getting a lot of looks at this now. A lot of reminders. Probably should have bumped that over a little bit.
Mr. Oslo, just a question. What did you get for the vertex in problem number 5?
That was yesterday. I haven't redone it.
Oh, right. That was, wait, well, no, that wasn't yesterday.
Let's see. P and Q are 3 and 7. So the average of 3 and 7 is 5. So the x coordinate would have been 5. Okay, and then if you plug that in, you get
Oh, never mind.
negative 4. So 5, negative 4. All right, now back to this one. Okay, so here's my vertex here. I have this point. I have these 2 points are the same distance from the axis. So the only point I'm missing is the reflection of this across the axis of symmetry. So this point is at -8. So the other point will be at -8, but it will be however far this is from the axis, which is what we learned in geometry. This distance, this is going to be the same on the other side. So 1.5 on the other side will get me here at 3, -8. That's my other point. And then there we go. Questions?
Mr. Knaus would get so angry at that graph, the parabola. He would get mad at us if we didn't draw the parabola with a not super sharp base because he just would get mad because the way it is. Well, yeah, because he doesn't want like the almost like a edge at on the vertex. He wants like a gradual going into the vertex.
Yeah, he wants it to be a curve, not a V. Are you criticizing mine, or are you saying how great mine looks? Which one are you doing?
Regardless.
I'm not criticizing it. I'm saying that Mr. Knaus would criticize it.
Oh, yeah?
Regardless, though, as long as you
I
have.
would say let him kneel down on one knee and try to draw what I'm drawing on one knee down here on, on a makeshift board.
Regardless, though, Mr. Ostal.
On the smart board, I can get a nicer parabola. Go ahead, sir.
It doesn't look that bad.
No, that's not the point. The point is that as long as all the points are on the graph serves its purpose. So it doesn't matter if the edge is a V or a curve or
it's a
anything
bit
else.
trivial. Okay, any other questions about this problem before we do the next one? Okay, start on the next one if you haven't already. Number 7. Okay, so y equals, a is -1, by the way. Okay, here we go. P is -1, Q is 5, vertex, so you can do these pretty quickly, is 2. That would make this negative. If I plug in a 2 here, you get 3. Look at that. So they're always the same. So you get +9. Okay, and then, so you can quickly get these points. And then what is the other point? Y-intercept? Y-intercept is APQ. So you got -1 times -1 times 5. So it's just 5. And you go to graph. Let's see, what do I have? I have quadrant 1. Okay, and I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one opens down because of the negative. Okay, so you might sketch a little just to remind yourself. It may or may not be helpful. Okay, I have a root here at -1. I have a root at 5. 1, 2, 3, 4, 5. Okay, my vertex is at 2, 9. My y-intercept is at 5. Axis of symmetry goes through 2. So x is 2 is the equation of the axis of symmetry. Okay, and then so this is 2 away at 5. So this will be at 4, 5. And that's all there is to it. Okay, I tried to do like gradual on this side in honor of Mr. Knaus. Okay, questions about that problem? So you see, once I stop explaining so much, some students get the idea that, oh, these are so long and tedious. Well, and you're getting that based on how long it's taking me to do them. It's taking me that long because I'm stopping to explain and answer questions. Once you get the hang of it, you can see, and even still I explain stuff, but you can see that this in this form is kind of nice. You can get all the points you need quickly. Questions? Okay. All right. Does anybody need to see number 8, or do we want to move on?
Okay, the number you're gonna be squaring is gonna be, actually, the result of the squaring is gonna be negative p squared plus 2pq minus q squared over 4.
Yeah, that's too complex. And I think we already figured that out. Yesterday, we figured that out and said it's more complex than it is worth.
Are you trying to find a form? What was it you were trying to find a formula for?
The square.
The y coordinate of the vertex.
Ah, yes, now I remember. Yes, you did say it was too complex, so you substituted the negative v squared or 4a or whatnot into the equation.
All right, nobody.
Okay, either way, it's gonna be a times q minus p over 2 times p minus q over 2. I think that's easier.
Wait, Ms. Rosendahl, for 8, we just need to find the vertex, right?
What is the maximum height? The y coordinate of the vertex.
Yeah.
So what would the average of p and q be here? P is 0, q is 50. So the average is 25.
Yeah.
Right. And then the y coordinate of the vertex would be plugging in 25. So it'd be 25 times negative 25. So it'd be positive. So you're going to have 625 times 0.025. You just plug them in, and that's what you get. If you want it, it's 15.625 feet.
Okay.
All right, let's move on to the next idea, which it's going to get a lot of criticism, I know. FOIL method, you can change quadratic functions from intercept form or vertex form to back to standard form by multiplying algebraic expressions. One method for multiplying 2 expressions, each containing 2 terms, is FOIL. Of course, FOIL is just a mnemonic device, right? It's just to help you, like SOHCAHTOA. It's not a mathematical, truth to the world. It's just
No, it's a method, but it's not a good method. And at least SOHCAHTOA.
The property that's always true is the distributive property. So it's just distribution. Okay, so it's just the same old idea of distributing. So if you have multiple parts, okay, and you have okay, then you're going to have to do A times each of these, plus you're going to have to do B times each of these, plus you're going to have to do C times each of these. So each term in here must be multiplied to each term in there.
So you're gonna get 9 terms if there's 3 terms.
Yeah, and so that's what it's just the distributive property with multiple elements in the group. Okay, so and I think everybody's fine with that. We learned that in 6th grade. It's a standard 6th grade standard for regular 6th grade. So you guys are well beyond that, and it's really trivial to argue about the name of it. I don't think that it causes too much confusion later on. I could be wrong. But anyway, I think you guys know how to expand, do the expansion of the x plus 4 times x plus 7. This is called expanding it, okay? Because you can see this is tighter and this is expanded out. It just, you can see how it's 4 separate terms instead of the product of 2 factors. Okay. So, I don't want to go too far. The directions on this next one say to do this, and I'll give you, 30 seconds to do this. Write y equals -2 times x plus 5 times x minus 8 in standard form. Go ahead. So now that we have the three forms, it looks like they want us to be able to go in and out of the forms. All right. So what you might do here is you might leave the -2 alone and then put a bracket and go ahead and start your distribution. X times X, X times -8, 5 times X, 5 times -8. Okay, and then maybe combine these, right?
Wait, why are we doing this?
Because that's what it asked us to do. It asked us to write it in standard form.
Oh, okay.
And then you just distribute the -2. Be careful with your negatives. And then we fulfilled what it wanted us to do. Questions about that? And you can see where if I tell you to graph this, how would you graph it when it was in standard form? You would
Start at
negative
0 and go to 1.
You would make a t-table.
-b over 2a would find the middle, because you don't want to make a t-table as starting at 0, 1, 2, 3, 4, 5 if the middle of the graph is somewhere at 2100, So the first thing you need to do is find the middle using what we learned. The x coordinate would be -b over 2a. That would get you the middle. Then I would pick 2 points to the left and 2 points equally spaced on the right, so that you could just find 2 more points and then take their mirror reflections across that axis. Okay, so that's how we would do it in this form. But you could always factor it and put it in this form, all right, if you wanted to see the intercepts right away. So this way, if you wanted the X-intercepts, you have to solve the quadratic formula to get the roots of this. If you were to have factored it, then this would be in the form where you would see the roots right now. Okay. You could solve this and by factoring, which would be the same as this, when y is equal to 0. That's another thing you could do. So they're all pretty much connected. They're not really different. All right. Any questions about that? Or no questions? Okay, let's go to Vertex Form and see what that looks like. Okay, try that one. Write it in standard form.
Which one, Mr. Rosenthal?
Examples.
Oh, it's just that when I swap the screen, it doesn't show the example, and I can't read it when I don't swap the screen.
Guys, you
Okay,
know what you can do?
Sorry.
On
What you
the
can do is
option one, put
X minus 1 squared minus that. What? Oh, there we go. Oh no, wait. It looks like
What's the problem? I'm sharing my screen. It's on there.
looks like mine.
yeah, all you have to do is open up so I'm in full screen mode. I'm not sure if it's the same if you're not. But what you do is you pin his video and then you basically just select his.
Oh, there we go. I just
Yeah.
entered full screen mode and it shows.
Yeah, exactly.
Okay, so at this point, you're squaring this binomial. All right. The binomial expansion using Pascal's triangle, I'm sure, from Mr. Knaus. Yes or no? It was on my back wall on that purple poster.
Yes, but not from Mr. Knaus. From
He
you.
did not teach it to us.
Okay, check this out. A plus b to the 0 power. What is it?
1.
It's 1.
So Pascal's triangles all the coefficients of all the terms, right?
Well, you're going to see that right here. So a plus b to the first power is a plus b. Okay, so it's 1a plus 1b. Okay, a plus b to the second power, which is what you're going to do up here. Let me kneel down here. Okay, what does that come out to? 1
A squared plus 2.
plus 2ab plus 1b squared. Okay, and what about this one? That one is going to come out to 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And I'll do one more. Notice you didn't see me, I didn't memorize that, by the way. I'm adding 1 and 2 to get 3. I'm taking 1 off of this exponent, and I'm adding 1 to the b exponent. Where's the b here? It's b to the 0, right? If you don't see it, it's a 1. B to the 0 is right here. B to the 0 is here. You can always throw in a b to the 0. So if I'm going to take 1 exponent away from a, I'm going to add 1, and so b to the 0 becomes b to the 1. Then it comes a to the 1, then you add 1 to the b to the 2. So that's what you do with the variables. And then a to the 0, it's gone, b to the 3. So watch, I'll do the same thing here. So it starts with a 1a to the 4th. Okay, plus, okay, so now I need to get the coefficient, it's 1 plus 3 from above. 4, now what do I do with the letters? I drop 1 from the a, and now b shows up on the scene. Plus, okay, 3 and 3 make 6. Okay, then I have a squared b squared plus, okay, 3 and 1 make 4. Then I get ab cubed. Okay, and then I get 1 at the end. Okay, and so that'll be 1, a drops out, b to the 4th. And if you notice, you're building a triangle. This is Pascal's triangle. And then Pascal's triangle removes the letters, the variables.
Which is just the same as making each variable 1.
I suppose so. And so this is what you see when you see Pascal's triangle. There it is. Okay. So when you come up here, that's the connection between this and that. As you go through algebra and algebra 2, you are going to be doing a plus b cubed and a plus b to the 4th and things like that. And you're going to use Pascal's triangle to do that.
Not to solve them though, although to solve a quartic equation.
Okay, here we go. So here, I'm going to write this. F of x is equal to 4, place my brackets, x squared minus 2x plus 1 plus the 9. F of x is equal to, distribute, 4x squared minus 8x plus 4 plus 9. F of x equals 4x squared. This is how I want you to show your work, your homework on tests. Don't be lazy about it. Just write it all out. It's a really good math practice. So many mistakes are made because students don't write it all out. It should look nice and neat, everything written. It doesn't take much extra time. Your brain makes it a big deal, like you're doing so much extra writing. You're not really. It makes it a lot cleaner, and the flow of information, it stays intact. It starts to lose its integrity when you start leaving stuff off because you're just, okay, I know it's f of x. Why do I have to keep writing? Okay, it does take away the integrity of it when you start removing stuff until mistakes start being made. That is my wisdom to give to you. It's not math. It's the wisdom, having been doing this a long time. I'm telling you that that's a good practice to write it all out. Questions?
Hey, can you hold on the board for a little bit more?
Can I what?
Don't erase the board yet.
Oh, don't erase it. Okay.
I believe there's a phone buzzing.
That's mine. I'm sorry. It'll stop soon.
Is it Miss Huff again?
I know, unknown number, but it was not reported as spam, so they'll leave a message if it's important. Any questions? Okay, let's see what else we have here. Okay. All right, so here's more practice. Does anybody need to see? Look at those for 30 seconds. Just let your eyes go over each one. Think, would I be able to turn this into standard form? Yes, yes, yes. I don't think anybody's gonna have a problem. It's just order of operations, really, distributive property. So if nobody needs to see any of these, I will move on. But if you do, let me know and I'll gladly do the problem for you.
Can you do one of the problems with the term at the end?
You tell me which one. Take your pick.
14.
Okay, g of x is equal to 6, x minus 4 squared minus 10. Okay, order of operations, you're going to square your binomial to expand it. So in the meantime, that 6 has to wait its turn. I'm going to put brackets here so I can put the result of this inside. Okay, so x squared minus 8x plus 16 minus 10. G of x is equal to 6x squared. Now I'm distributing. Minus 6 times 8, 48x plus 96 minus 10. G of x is equal to 6x squared minus 48x plus 86. Okay. Anybody else? Any others? I don't have the chat up. Actually, I should have the chat up because some of you chat. Can you go over how to graph with standard form? Oh, yes, I can do that. Okay. I think I talked about it already. When an equation is in standard form, you don't know where this parabola is going to be. You know if it's flipped upside down or not, but you don't know where this vertex is. Okay. If I start picking, if I do an XY table and I'm, and I pick 0, 1, 2, 3, 4, or I pick -2, -1, 0, 1, 2, so that it's centered on the axis. When x is 0, when is that going? Where am I going to find the point on that? It's somewhere way up there. And then the next one will be way up there to the right. And I'm going to get these 5 points up here. Can you see me? You're going to get points that are way up there, and you're going to get points that are way up here like this. And when you try to graph it, you're just going to have that. You won't have the rest of your graph. So the idea is find the middle, and then wherever that is, let's say this is at 2432. Right? Let's say that middle is at an x coordinate of 2432. You plug it in and you find out what the altitude is here. Okay, how high up that is from the x-axis. So then you have a coordinate. That coordinate is 2432, and let's say it's 171.725. Okay, now you found that point. Now, what I'll do is I'll pick some coordinates that are maybe to the left of it, a certain amount of space. Maybe I'll pick a coordinate that's to the left here, and then I'll pick the same distance the other way here and here, and I'll just, in my t-table. So I found this middle point here. I found 2432, and when I plugged it in, I got 171.725, right? And then I'm going to plug in, that tells me, okay, I'm not going to use 0, 1, 3, and 4 as my other points. I'm going to use maybe 24, I don't know, 2416 and 2400, and maybe 2448, and maybe 2464. Right? And those are the same, this is the same distance as that, and that's the same distance as that. So if you just plug in those two, you'll get some answers. And then those will be the same answers here. And what you're getting is you're getting 2 points to the left, which will mirror 2 points to the right. And then you'll have your parabola. So that's the basic strategy that you're going to use when it's in standard form. Okay? The Algebra 4.2 evens homework says it's due today. No. Okay, let me clarify. I thought we were going to be done. Okay, I thought that. We didn't finish it, so it's due next Friday. Okay, so the homework you're about to be assigned is due next Friday, even though in Schoology I have not changed it. I really don't want to go back and change it. It's very trivial. I want you to hear me now, all of you. Don't worry about it being late. Okay, it's not late. It says Schoology says it's late, but Schoology is not in charge of things. Okay, I'm not counting it as late. It's due next Friday. Okay, tell your friends.
Mr. Rosenthal,
Yes.
Is that both
do
of
one
them?
more, please.
Or just one of them?
Oh yeah, we reached 60 people. That's great. Do one more. What? Which kind?
Can you do number 15?
Mr. Rosenthal, we had 62 at one point.
That's great. I feel like maybe because Mr. Lauchu's email went out saying that we need everybody to show up. So we got a few more. Okay.
Yes, that's true. But
No student got an email.
Yeah, parents did.
teachers aren't actually going to start taking attendance at Zoom meetings, are they?
They are, but
What?
we don't know when.
What?
Maybe next week we will, because we're switching our Zooms over to LAUSD Zoom accounts. And when I record it, it will tell me who has shown up. I can do a report. And then we're going to be sending them to the counselor, our reports. And then the report,
Yeah.
she'll see who's
Yeah.
not.
What about things
That
like
won't
office
count
hours?
on a report card, will they?
I don't know that yet. Okay,
That won't count
Daniel,
on
here we go.
report cards, will they? Right?
Say that again.
Because the report, since the report cards are already submitted, that won't count, will it?
Oh, you're talking about the 10-week?
And I'm talking about in general. They said they would preserve everything they had before the outbreak.
Yeah, I don't know if they said they'll preserve everything. I think that they were talking about the academic grade. I think everything else can be recorded.
Your
Like-
grade can go up, not down.
Work habits and cooperation, it's a little unclear whether those are subject to change.
Also, Mr. Rosenthal, my most recent report, never mind, actually, I'll discuss this at office hours.
Daniel, are you watching?
Yes.
The negative is now being distributed. And those will cancel each other out.
And then you could just do minus b over 2a and plug in.
You could have anyway. Negative b over 2a doesn't care if you have a constant out here, if you have a c value other than 0. Okay, anything else here?
Nope.
All right. Let me look at the chat. More people are coming to Zoom because we moved on to Algebra 2. So, I don't understand. Why is that a thing? Oh, they're interested. They're more interested in getting ready for Algebra 2. I don't know. Okay, so here's your homework. I need to answer a question. I've gotten a few. Mr. Rosenthal, I don't see the homework for 4.2. That's because it's now attached to the lessons. You will not get any more homework in the Zoom homework folder. That's done. That was my first time out. As I learn, I change things to become more efficient. It's more efficient to just have it attached to the lesson. And that way it's all in one place. So if you need to answer a question you're having trouble with, the lesson's right there. You just scroll up to the lesson, look at it. It's like, it's like having the book. Okay? So it's more efficient there, and you're just going to do all the evens. I don't know what the textbook is called. It's Algebra 2. McDougall.
Big Ideas Math. It is online. You can see the lesson and the homework if you go to Big Ideas Math Algebra 2. You have to do Common Core High School.
It's if you just look up.
It says the book Big Ideas.
Yeah, but
Big
this,
Ideas Math.
this is an older book.
Like you can.
If you
Oh,
look
you.
at easy
Oh
access,
yeah, this is a different
there's
book.
a website. Okay.
This is a different book, not the one that's on the School Science Academy website.
No, it's not. Okay? All right. All right, so let's move on then. All right, so that means go ahead and go back onto Schoology, everybody. And you're going to open up now. I'm going to do the same thing right now. You're going to open up 4.3. And I'm going to do that too. 4.3. Let's see what we're learning. I'm excited for 4.3. We really took our time in 4.2, but that's good. We don't want to go on unless we're ready to go on. Okay, and then let's go ahead and open that. Okay.
Ta-da.
And then let's go ahead and share that screen. Is this it? Yeah. Okay, here's your warm up. Go ahead and start on that while I get it up on my screen.
I don't understand why they have decimals like this.
You have your calculators. They want you to start using your calculator in the math.
That's ridiculous. Well, first off, well, no, that's not ridiculous, but I mean, they're asking us to type the algebraic expression into a calculator because, oh, how do you evaluate x minus
Is that
5?
what they're asking you to do? I don't know if they're asking you to do that.
That's how it seems.
Okay, let me look at the problem. Okay, popcorn. I love popcorn. I've been eating more popcorn because of what's going on, just being at home, and I have access to popcorn in the stove. Okay, let me look at the problem. A kernel of popcorn contains water. Oh, okay, so that's how it works. The water expands when the kernel is heated, and then it reaches some sort of threshold and pops. Once the pressure, I guess, inside the kernel gets too much, it bursts open, and then the insides of it come outside suddenly, and then probably cool off suddenly. And then because they cool off suddenly, it hardens instead of explodes, right? That's interesting to think about that, the science of popcorn. The pressure gets so much inside from the water heating up inside that it bursts. The equations below give the popping volume, Y, in cubic centimeters per gram of popcorn with moisture content X as a percent of the popcorn's weight. Okay, so how big is the popcorn going to become when it bursts, when the kernel bursts? Is it going to be more with oil when you cook it in oil, or more with air? What would oil do to the kernel?
It's gonna be bigger with oil.
Would oil protect it from popping?
Oh wait, no, it's bigger with air.
Okay, if you allow more heat to build up before it pops, there will be more energy bursting out of the kernel, which will let it expand further before it cools off and stops expanding. Right? So you have to make it so that the kernel does not pop before you want it to. Then you'll get a bigger popcorn pop. All right? Will oil, and why would oil do that? Or would it not do that? Would oil make it pop?
It would be air.
It'd be air, because if you notice, air is steeper.
Yeah, if you take the graph of both of the functions, they have the same axis of symmetry, but air's y value is higher.
You can graph these in Desmos. For a set X,
that's what I do.
For a set X moisture content, there's going to be a larger popping volume for air. You can graph in Desmos.
X is the X, moisture content X as a percent of the popcorn's weight. So X is the moisture content. That's how much moisture is inside the kernel, right? Y is the popping volume, the outcome. Okay, let's just start looking at it then. Okay, A, for hot air popping, what moisture content maximizes popping volume? And what is the maximum volume? So your Y is the volume, okay, popping volume. So you're trying to maximize Y, which is going to be the maximum part of our parabola. Check to see that it opens down so that you have a maximum. You need it to open down to get a maximum. Yes, they're both negative. The A is negative. So that's going to be, there's going to be a maximum for both of these. Okay. Where is that going to be? Well, right now we have our problem in what form? Intercept form, right?
Intercept form, which is actually much easier for the Vertex.
So let's do hot air. And here we go. So we have Y is equal to negative 0.761. X minus 5.52, X minus 22.6. I do not need a P or a Q right now. I might need it in the future. Oh, wait, we want yes, we want P and Q so that we can average P and Q. Okay, but these are just P and Q right here. So if I'm gonna go ahead and average those now, and you can write them. P is 5.52. Q is 22.6, and I'm going to average those. So here we go, 5.52 plus 22.6 divided by 2. Okay, so my vertex is at 14.06. That's my X coordinate. All right, so I know as a percent of the popcorn's weight, the moisture content. So that looks like that might be 14.06% of the weight. All right, so when am I interpreting that right? X is the X is going to be as a percent of the popcorn's weight. So its moisture content at the maximum popping volume is going to be when the content reaches 14.06% of its weight. Okay, fine. Now, that does not give you the volume, though. You need this. You need the Y that goes with that. So we're going to have to plug that in. But look, if I plug it into one, I know I'm going to get it for the other. So I can square it. And they're the same sign. Okay? But wait a minute. 14 minus 5 is going to be positive. 14 minus 22 is going to be negative. So it's always going to be negative, and then it'll be positive when you multiply it. Okay, so I'm just going to do it once. 14.06, I'm going to plug it in here and subtract 5.52.
Are you attempting to find the vertex?
Then I'm gonna get the same thing but negative here, so I'm just going to square it.
Are you attempting to find the vertices, Mr. Rosenthal?
I'm finding the Y at the vertex X. I'm plugging in this X in here to find the volume when X is there at the maximum. That is the maximum X value. That is the maximum, that is the vertex, that's the vertex. So that vertex is the maximum point. That is the X coordinate of the vertex. That gives me the water content as a percent of the popcorn's weight. But the question is, what is that maximum value? Oh, it wanted to know the moisture content. What moisture content maximizes popping volume? 14.06. Okay, and then we plug that in. Now I have to multiply. I plugged it in here and I got 72.9316. Now I'm going to multiply it by this times 0.761, and I already canceled out the negatives. And this is what I got. I'm going to round it. It's about 55.5. Okay, and that's measured in cubic centimeters per gram. So what's the maximum, which moisture content maximizes popping volume? It's when the moisture content becomes 14.06% of the weight of the popcorn. Okay?
Mr. Oswald, does an Apple calculator have parenthesis feature?
Yes.
I believe, I believe it does. Yeah,
Does.
it's because I don't use my phone calculator that, well, I do, but never mind.
Okay. And then the maximum volume is this, 55.5 cubic centimeters per gram is going to be the maximum volume. Okay. And then, so this is for hot air popping. Now for hot oil popping, what moisture content? Same question. Okay, so here we go. Do the same thing down here. Hot oil popping. Okay, and then this one is negative 0.652, x minus 5.35, x minus 2.18. And we're going to get our answer now. Okay, so P here is 5.35, which is high, which is lower. Okay, and then Q is 21.8, which is lower. So it looks like these numbers are lower. Okay, that's going to give us a lower number here. It's going to lower the maximum values percentage, the moisture content percentage. In order to reach its maximum, it's not going to have as high of a percent of the weight of the popcorn needed to reach its maximum point. I wonder, is that going to affect is that going to lower the maximum point then?
Wait, so the higher the X, the better, or the lower the X, the better?
Let's find out. Let's just go through our investigation here. Okay, let's do this average. 5.35 plus 21.8 divided by 2 gives us, here's our,
Though, as a general note, if you graph the functions, you can see that the performance of oil and water doesn't really vary at lower moisture contents and at particularly high moisture contents, but exactly in the middle, where the vertices of both parabolas lies, where performance varies the most. You can see the widest gap between the points near the vertices.
Are you on Desmos?
Yes.
Yeah, well, but so you're saying the gap between the content, 13 and a half and 14 is not a lot. Is that what you're saying?
No, I'm saying that the closer you get to the vertices of either function, the more their performance varies. But the further you get from the vertices, the more their performance remains similar.
Okay. Okay, thank you for that. All right, now, and you're on Desmos doing that, right?
And at about 6.2 moisture content, I mean, their performance is exactly the same. The parabolas intersect.
Okay, great. Thank you. All right, so yeah, so if you guys want, you can always take these problems and put them on Desmos and look at them. It's a good idea. And then you'll discover things that I wouldn't have discovered here without graphing. Okay, so take a look at this. This is the moisture content as a percent of the weight of the popcorn at the maximum for hot oil popping. We plug that in. I'm going to do that now. Minus 5.35 gives me a positive. If I plug it in here, it'll give me negative of the same thing. So positive times negative is negative. Negative times this negative is positive, so you're not going to see me dealing with any negatives or positives anymore. Since this is the same absolute value as that, and I already have that value after subtracting, I'm just going to go ahead and square it here. I get 67.65 about. And then I can multiply it by 0.652. And that gives me 44.1. Oh yeah. Yes, you're right. So look at that value compared to that value. So you get a lot more volume from hot air popping than you get from hot oil popping.
At moisture content.
I think I know why. I think the oil, I feel like the oil heats the popcorn up faster.
Yeah.
I don't know. I see, this is where my science background is not there. I'm guessing that the oil can has a higher boiling temperature than water, right? So it requires more energy to reach boiling.
At 6.268,
which means
moisture
that
content.
it will obtain a hotter temperature, more energy will go into it. I don't know how that translates into the popcorn though, because you're not necessarily boiling the oil.
Wait, so hot air popping is better?
Hot air
Yeah.
popping gives you more volume to your popcorn.
Bigger popcorn.
Bigger popcorn, right?
Mr. Rosenthal,
Sure.
at 6.268% moisture,
Wait a minute, and the volume affects the density.
I already said that, David. They're the same.
If the popcorn kernel is used in both, it's the
Yeah.
same mass, by the way. The mass is not changing. So more volume does not mean more popcorn. It means less dense, fluffier. This popcorn is going to be more dense. So maybe you want the popcorn to be a little bit more dense. It'll feel more substantial when you eat it. This one will be less dense, airy, you know, feel lighter, you know? Okay. Any questions? Oh, look what it says. Graph the functions in the same coordinate plane. What are the domain and range of each function? Domain is what x could be, right? It can't be negative. You can't have negative water content. Okay, and then you can see at the root, at the other root, you can't go beyond the root. All right, so where would you find the two roots? It's at P and Q, right? P and Q are the roots. So it looks like the domain is between 5.52 and 22.6. Okay, so the x value, if it went to the left of 5.52, so let's take a look at what this looks like. So if you have this graph here, and here's your x-axis, right? And this is 5.52, and this is 22.6, okay? What do these y values mean? The volume, right?
Yes.
So if this is an X-intercept is 5.52, what does that mean the volume of the popcorn is at that point? It's zero. Yeah, it's 0, which means it hasn't popped yet. They're not counting the kernel as the popcorn. It's not popped corn yet, okay? So you can't get lower than that. So all of these values don't actually get to go into the domain. All of these values don't get to go into the domain. So the domain is between 5.52 and 22.6 practically in the context of the problem.
Wait, but why?
Because you can't, what is the volume of the popcorn at 5.52? The volume is the y-axis, right? It's on the x-axis. The volume is 0. It has not
Also,
popped.
only starts popping after that point.
Yeah, and so if you have less water content than that, it shows on my graph a negative volume. You can't have a negative volume. So all of these values are not in your domain because you can't have that. It's impossible. And you can't go beyond that either. All right, because you'd have negative volume according to our quadratic. Now, range values. Range values are what y's can be obtained. Well, you have your maximum value that we've already obtained in both problems. So the domain here, or the range here would be at maximum 44.1. The range of the other one at maximum would be 55.5. What would the minimum range value be? What's the lowest the volume could go?
0.
0. So my range would be between 0 and 55.5. And for the other one, it would be between 0 and 44.1. My domain for this one would be between these values. My domain for the first one, between these values. My domain for the second one is between those values. This P and Q. Yes. Yes.
Popping volume is the same at 27.654 moisture content, percent moisture content.
Yeah, so if you look at this other one here, 5.35 is very close here.
They both have negative 85.1.
Hold on, 21.8 is like right around here, right? So this one goes through there. And then the maximum of this one is lower, right? And it's okay, so this point was at 14.06. The other one was over at here and lower. Okay, this middle was here, 13.5. Okay, so this graph looks like this. Okay, so yes, right there where the parabolas cross is the solution to the system of parabolas. At that point, they will have the same water content and popping volume at that point. Okay? Now, how come they don't all pop? They all pop at different places, don't they? They don't all pop at once, right? So some of the popcorn's going to pop here. The popcorn that is the biggest is going to pop right when it reaches that. And then some are going to pop later, but they're not going to achieve as much volume when they pop later. It's very interesting to look at this problem. Okay. All right. Well, I think that's a good stopping point. We have another challenge problem after that. So you're dismissed. Now we're in office hours. Good job.
Thank you, Mr. Rosenthal. Have a good weekend.
Mr. Rosenthal,
Alright,
have
Mr.
a good rest of your morning and have a good weekend.
Okay, same to you. There's so much less
Mr.
pressure right now. These lessons are just all exploration and fun. We're not trying to get anywhere. We're just it's the journey itself. There's no destination we're trying to reach. I really enjoy this because we get to really have fun with problems and look and tear this math apart. Anyway.
So, Mr. Rosenthal, what I said I was going to be for office hours is why was I given an S on my report card for the last period? I just received it, and there's an S for mathematics, work habits, not cooperation either.
That would be because there might be some missing work.
Missing work. Would this grade be the grade we received for the work we did over the past period of time we haven't been in school, or is this the grade from school?
No, absolutely not. Only what was there before.
Only what was there before. Well, there was no missing work before we left. I had zero missing work.
Oh, really?
The only missing work was a pair of assignments that I didn't turn in because I was absent, and the next day we didn't have math, and the day after that it was the start of the quarantine, and those were registered as missing only an entire week after we started the